Hello, Krishna. My voice is audible.
Good evening, sir.
Oh,
Yes.
good evening. Okay. So, Krishna, you have done the homework?
Yes, sir.
Any doubt?
No, sir.
Okay. So, all the questions from NCERT and miscellaneous, or some questions are left?
Sir, you said few questions only, right? Not complete. So,
Okay, not issue. This week, please complete the homework.
okay, sir.
Okay, then we will start then for the topic. We were doing the product rule, product rule of differentiation, and in that we have done some questions. So just give me a minute. We have already completed these formulas. Then we have these formulas where we have a log and exponential function. Okay, we will try to understand that what is log and what is the exponential function. Okay, so let me start with this. Now we will discuss about the exponential and logarithmic function and logarithmic function. Okay, so suppose we have 2 cubed. Okay, this is equal to 8. Now 2 cube is equal to 8. Now the log goes in this way. Then if you have log 8 and you have a base 2, then the log says what should be the power of this 2 so that you will get 8. Okay, so log says that what should be the power of 2 so that you will get 8. So that means 3. Okay, so log work in this way. Here what happened? 2 cube should be equal to 8, and in log, whenever we have a log 8, and there should be some base. Okay, this is a base. Similarly, in log, this base come here. So we will solve it like this, that what should be the power of 2 so that we will get 8, so that will be equal to 3. Now, for example, if we have 25, okay, and here we have 5, then what should be the answer?
5.
2. Okay, what should be the power of 5 so that you will get a 25? So it should be
2, sir.
It should be 2. Okay. Now we have one more number which is represented by E. There's a Euler number. Okay, this is actually a Euler number. And its value is 2.718 and so on. Okay. Now, as we have checked here, we can have any number over here. We can have any base here. Now, for this one, if our base is 10, here we have any number. For example, if you are taking an x, if the base is 10, then this is called common log. This is called common log. Okay. Now, if you have a base e, then this is called natural log. This is called natural log. Okay. If the base is 10, you will say this is a common log. And when the base is e, then we will say that this is a natural log. Okay. And most of the time, when base is not given, then we will consider it as a natural log. So for example, in your books, if it is given log x, base is not given, then it will be considered as a natural log. Okay, Krishna?
Yes, sir.
Clear up to here?
Yes, sir.
Okay, so this is a logarithmic function. So before the calculator was invented, uh, the people used to use this logarithmic function to do the calculation, because there are many properties of logs, as well as there is a log table which earlier was there at the back side of the book, and from that table we used to do the calculation. We can find any of the value of the log, and as per the table we do the calculation. So it was used before the calculator was invented, but still in some, I guess in chemistry, you have to use that log table. Okay, so this is done, logarithmic function. Next, we have an exponential function. So we have this number e is equal to 2.718 and so on. So when we have this e to the power x, then this is called the exponential function. And it is called exponential function. Okay, logarithmic function and exponential function, these two are related to each other. How they are related? Suppose we have this log e and to the base e. So can you tell me what is the answer?
So 1.
1. Very good. Okay. Now, if we have like this, y is equal to log x. Okay, there is nothing, so that means e. So we can write it like this, that what should be the power of e, so that we will get x. So we can say e to the power y is equal to x. So this exponential function and logarithmic functions are related to each other by this relation. So if we have a y is equal to log x, then we can say e to the power y is equal to x. This is clear, Krishna?
Yes, sir.
Okay, so these are the relation. This is e. So these are the relation between the exponential function and the logarithmic function. There is still many properties, more properties of log, which we will do later on, because we don't need that properties in this chapter. Okay, so we can do that later on whenever we need to use that, whenever there is any question where it is required, and I will let you know. But right now we just need this much of information, that what is a log, what is e, what is the exponential function, and what is the relation between the log and the exponential function. So these are the relations. Please note down this. Then we will again analyze these formulas, because in questions we need all these formulas. Okay, so please note down this and let me know. Then we will further continue this topic. Please let me know once this is done. Okay.
Done, sir.
Okay, then we will start the next topic. Okay. Now, we will analyze the formulas one by one. So first, we have already discussed that e to the power x, this is exponential function. So what is the derivative of this? This remains the same, e to the power x. Okay, and how we get this formula, this needs to be proved by the first principle method that we will do at the end of the chapter. Okay, I don't want to disturb our sequence. Right now we are doing the differentiation by the direct method. So we will continue that, and after completing the complete chapter, we will do the proof of these formulas, e to the power x and log x. Okay, so the first formula is whenever we differentiate the exponential function, we get the same one. E, you already know, it's a Euler number which is given by 2.718. Now, if we have this one, a to the power x, okay, a can be any number, 2, 3, 4, 5, 6, any numbers. Then what happened? If we will differentiate this one, we will get a to the power x as we are getting here, as well as we will get a log a. No base is given here, so that means it is a natural log. Okay, Krishna?
Yes, sir.
So for the exponential function, the derivative is e to the power x, and while for the a to the power x function, we get a derivative a to the power x into log a. Now similarly, if we have a log x, then the formula will be 1 by x. Okay, here no base is given, so that means this is a natural log. Now suppose if the base is given, but this is not e, it is not a natural log, then what happened? It will become 1 by x, as here. After that, you need to write log a. No base is there, so that means this is a natural log. These four properties are clear?
Yes, sir.
Okay, very good, Krishna. Please note down this, and then we will again continue our question. Okay, I guess we have already noted
Yes,
these
sir. You
forms.
told
Okay.
already to write it down.
Okay. Then we will start the next. Here, these we have already done. We have started the product rule. These questions has been done, and you need to do this question. Here you have x cubed e to the power x into sine x. So you have three functions. So which rule you will apply? Krishna, you need to differentiate this. So which rule will you apply?
Uh, so first n into x power n minus 1 and
Very good. So you can take any two functions. Suppose, for example, you can take this as a first function and this as a second function. Okay. So when you need to differentiate the second function, then here again you will apply the product rule.
okay, sir.
Okay. Okay, Krishna, then please try to do this and share your answer. Or if you have any doubt, then please let me know. Hey, Krishna, you have completed this. Let me check. So 3x square. Then,
There is e to the power x. I made a mistake.
okay, let me solve this. So this remain as it is, x cube, and we have differentiated the second one. So e to the power x into cos x plus e to the power x into sin x. After this, the second will remain as it is, and we have differentiated the third one. So this is 3x squared. Right, getting the same answer, not matching. So you have written 3x squared and then e to the power x sin x plus. Uh, Krishna, first of all, suppose we have taken this one, x cube. This is the fx. Okay, after that, we will differentiate this function. So what is the derivative of this? This one?
Yes, sir.
Okay. Now, as per the product rule, now this function will remain as it is. And we will differentiate this function x cube. Okay.
So, sir, we should use the product rule 2 times, right?
2 times because there are 3 functions. So treat this as a single function first of all. Then I will show you how it can be right. X cube remain as it is. Okay. We will differentiate this one, e to the power x sin x. Then e to the power x sin x remain as it is. We will differentiate the x cube. Now here, these are 2 functions. So again, we will apply the product rule here.
Yes, sir.
Okay. Because there are 3 functions, that's why we need to do this. Any doubt in this?
No, sir.
Okay, then.
Just a second.
Yeah, sure. After this, please start this question. Okay. And let me know if you have any doubt in this one. Krishna, let me check. So x remain as it is. You are differentiating the next one. So that will give you, for example, sine x by x. Okay, I guess Krishna, you have missed something. Okay, so we will differentiate this one. Okay, dx x sine x log x. Okay, now what happened? We will take this as a first function and this complete as a second function. Okay, so first function remain as it is. We will differentiate the second one, sine x and log x plus sine x into log x, and then differentiate the dx. Okay. Now x into derivative of this will give you what? Sine remain as it is. What is our derivative of log?
1 by x.
1 by x. Krishna, I think you are facing some issue in these types of problem. Can you
Yes,
tell me?
sir.
Yeah. Can you tell me which is the difficulty?
So because it is 2 times, right? I'm getting trouble in that, sir.
Okay. Okay. So always in these types of problem, take one as a first function and second and third as a second function, the complete one, and just apply the property.
Okay.
Okay. So this clear up to here?
Yes, sir.
Okay. Now, if you're differentiating this one, then you have a two function again. So this as it is, you'll differentiate this one plus log x and this one plus sine x log x, and dx by dx is 1. This is x. Okay. This is sine x. Now, what is d of log? 1 by x plus log x. Now, what is this? Cos x plus sine x into log x. Okay.
Yes, sir.
So this will be your answer. You can write this x in the denominator of this, and this is sufficient. This is final answer. Any doubt, Krishna?
So we can take any 2, right?
Yeah, that's your wish. You can take this x sine x as a first function, second as a second one.
Okay, sir.
Okay. And what is the derivative of log x to the base a? Derivative of this log x to the base a. Just check the formula.
So a power 1,
1 by x log
1
a.
by x log a, right?
Okay, to the base. This clear?
Yes, sir.
Okay. Okay, Krishna, then this question is completed. Please start the third one. Okay. And let me know if you feel any doubt in this.
So I got the answer, sir.
Hey, Krishna, what's answer?
So x power n 1 by x log ax plus n log ax into x power n minus 1
Okay,
the whole into e power x
okay,
plus,
then
yes sir.
okay, I will check it. So, Krishna, which functions you have taken as the first and the second one?
So x power n log ax is 1 and ex I separate.
As the second. So this complete is one, and this is second.
Yes sir.
Okay, okay, very good. So as per the formula, we will write like this: x to the power n log x to the base a, and we will differentiate exponential function plus exponential function will remain the same. We will differentiate the x to the power n log x to the base a. Okay, now this remain as it is, x to the power n log x to the base a, and here we will get the exponential function plus this remain as it is, and we will differentiate this, and x to the power n remain as it is, and the derivative of this is 1 by x log a plus log x remain as it is to the base a. We will differentiate this, you will get nx n minus 1, nx n minus 1. Okay, Krishna, you are getting the same one?
No sir.
Uh,
I think there's a mistake somewhere.
okay, okay. Please check then which step you have done the mistake. Okay, because I guess this was our last question. So if required, I will give you some more questions, but please check where you have done the mistake. Hello, Yusra. You're just fine.
Hello, good evening, sir.
Good evening. Yusra, you were absent yesterday, so you have checked the recorded
Yes,
lectures?
sir.
Okay, okay, okay. So,
No, sir. Actually, I had my physics exam today, so I couldn't.
okay, 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 okay. Now the exams are over. Yusra, exams are over.
No, sir. Today was my first exam, physics.
Okay, 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 okay. And when is your next exam?
So my next exam is on Wednesday, that is chemistry.
On Wednesday. Okay. So, Yusra, we have already started the further differentiation by the direct method. Okay. So after this, I will start a new topic of differentiation. So please try to understand that. Okay. Krishna, this run,
Yes sir.
where you have done the mistake?
Sir, I think that conversion of log to differentiation of logs.
Okay, okay. Now is it clear?
Yes sir.
Okay, okay. Very good. So Krishna, now we will start a next topic. Okay. So next is quotient rule for differentiation. Okay, so Yusra, I guess you were there when we were doing the derivative by the first principle method. Am I correct? Yusra, your voice is not audible. Yusra, you can reply me on the chat box. Okay. Yusra, please reply me because we need to start the second one. Okay, Krishna. Then we have done the product rule. Now we have a quotient rule. Okay, this is not very good. This is not quotation rule. I will correct this. This is a quotient rule. This is a quotient rule for differentiation. Okay, so when we will use the quotient rule, when we have two functions which are in divisible. Okay, Krishna.
Yes, sir.
Okay, so we have this formula. Quotient rule for differentiation. Here, what we will do. Suppose we have two functions which are in differentiation, fx and gx. Okay, then what we will do, we will write the denominator as it is. We will differentiate the numerator minus numerator as it is. We will differentiate the denominator by denominator square. So I'm saying that if we have two functions like this, then what we will do, we will write the denominator as it is. We will differentiate the numerator minus numerator as it is. We will differentiate the denominator, okay, by then denominator square. This clear, Krishna?
Yes, sir.
Okay. So please note down this. Okay, and then we will try to do some questions. Yusra, my voice is audible. Yusra, you can reply me on the chat box. Okay, if you have some network issue, please reply me on the chat box. Krishna, confirm me once this is done, then we will try some questions.
Done, sir.
Now suppose we have this question, sin x by x. Then as per this formula, first of all, write the denominator, differentiate the numerator, minus numerator, differentiate the denominator by denominator square. Okay, this is equal to x into cos x minus sin x into 1 by x square. There is no need to write down this question. Please let me know. This clear?
Yes, sir.
Okay, and I will suggest you to please write the formula every time you are solving a question. Okay, in this way, after some time, you will automatically learn this formula. Okay, please try this. Yeah, that's the question. E to the power x by 1 plus sin x. Please try this. And user, please reply me on the chat box if my voice is audible to you. Okay, so user, we have started the differentiation. First principle is completed. Okay, so whatever the formulas we have derived by using the first principle, we will use that formulas here. Okay, we will not solve these questions by the first principle. We will directly apply the formula. So we have a list of formulas which I will write here. So for example, okay, if you will see our previous lectures, then you will find all these formulas there. Sin x dx is equal to cos x. Okay, and suppose third is if you have any constant, then its derivative is 0. There are many formulas, but for this question, you just need these three formulas. So you need to note down all these. Now, if two functions are in division, so for example, in this case, here we have first function, here we have the second function. If two functions are in division, then we will use the quotient rule for differentiation. Okay, this is not quotation rule. This is a quotient rule. I will correct the spelling. This is a quotient rule. So if two functions are in division, we will use the quotient rule. Then how can we use it? So for example, if we have a function fx, we have a function gx, we need to differentiate this. Then how can we do? Denominator remain as it is. We will differentiate the numerator, okay, minus numerator will remain as it is. We will differentiate the denominator by denominator square. Okay. So for example, related to these formulas, I will take this question. Ex by sine x. Suppose I've taken this question. Okay, we need to differentiate this. Then what is the formula? First of all, write the denominator sine x. Differentiate ex minus e to the power x. Differentiate sine x by sine x whole square. Whole square. Now this is equal to sine x. E to the power x will remain as it is. Minus e to the power x. This is cos x by sine x whole square. Okay, Isra, this is clear?
Yes, sir.
Okay. And there's no need to write down this answer, this question. Please start with this one. Okay, and Krishna, if you have done, okay, you have shared the answer. So minus e to the power x cos x by 1 plus sine x whole square. Very good, Krishna. This is correct. Okay. Now, Krishna, please start the second one. And Yusra, please share the first answer once this will be complete. If you have any doubt in this, okay, because you have missed the previous topic, then please let me know. I will help you in solving the first question. Okay. Yes, yes. Actually, you have missed many classes. That's why you will face issue while doing this. Okay, but once you will check our previous videos, then these are very simple questions for you. Okay, so we need to differentiate it. Okay, I will write here. We need to differentiate this. Now, what is the formula? Formula is, you can see at the top. What's the formula? Write the denominator. This is the denominator. Write the denominator. So, Yusra, what is the denominator?
So 1 plus sine x.
1 plus sine x. Very good. Then, as per the formula, we need to differentiate numerator. What is numerator? E to the power x minus fx means numerator. Differentiate the denominator. So that means 1 plus sine x by 1 plus sine x whole square. Now this is equal to 1 plus sine x. Now the numerator, this e to the power x, we have already told you that the formula for this is again exponential function minus exponential. We will differentiate this one. So the derivative of 1 is 0 and the derivative of sine is cos x by 1 plus sine x square. So this is equal to, open this bracket. No, sorry, there's no need to open the bracket because we can't solve it further. So minus e to the power x into plus cos x by 1 plus sine x whole square. This is clear, Yusra?
Yes, sir.
Okay, very good. Yusra, then please note down this and start the second question. Okay, you
Yes, sir.
have done Krishna. Hold on. Krishna, your answer is x plus cos x, 1 plus cos x minus x plus sine x, 1 minus cos x. Very good, Krishna. This is correct. Okay, and Yusra, please let me know once you will note down the second question so that I can change the slide.
Yes, sir. Done.
Okay, very good. Then please start the second one and let me know the answer. In the meantime, Krishna, please start the first one. Okay, please do the first question. And Yusra, if you will face an issue in the second question, then please let me know. I will help you solve it.
Yes, sir.
Please let me know, Krishna, if you have any doubt in this. Okay. Okay, Krishna, this is done. Let me check. X square minus 5, then you get a 2. If we will solve it, we will get x square minus 5, and you will solve it, you will get a 2 minus 2x plus 3, where 2x by denominator square x square minus 5 whole square is equal to x square, this bracket, 2x square minus 10 minus 4x square minus 6x by x square minus 5 whole square. Okay, so this will give you minus 2x square minus 6x minus 10 by x square minus 5 whole square. So you are getting the same answer, but there is slight change in the sign.
Yes, it's minus 6x.
Yeah, it's a minus 6x. Very good. Krishna, please start the next one. Okay. Okay, Krishna, very good. I will check your answer. Yusra, please reply me if you can hear my voice. So, Yusra, even you can reply on the chat box, okay? Then you will differentiate the numerator, you will get a 1 minus numerator x plus 3, differentiate the denominator, you will get a 2x by x square plus 1 whole square. So open this, you will get x square plus 1 minus 2x square minus 6x by x square plus 1 whole square. Yusra, please reply me in the chat box, okay, if you can hear my voice. Minus 6x plus 1 minus. Very good, Krishna, that's correct. Krishna, then please start this question. Okay, Yusra, then start with you can start with third question, okay? I will give you the formula formula for derivative of tan x. This is equal to sec square x. Okay, and for the constant, I have already told you that the constant derivative is 0. Okay, sir. Please use these formulas, apply the quotient rule, and try to solve this question. Third.
Yes, sir.
Mitra, this is a very new thing for you, new topic. So if you have a doubt, then please let me know, okay? I will solve this question. Okay, sir. Krishna already know all the concepts. So
Yes.
I know he can solve it. But for you, Yusra, please let me know. This is your first class. So please tell me if you have any doubt. I will solve it. Okay, Krishna, you got the answer. Okay, Yusra, I will check. I will do this question. Now here, what we will do, we will write the denominator 1 minus tan x. Okay, we will differentiate the numerator 1 plus tan x. Now minus 1 plus tan x as it is. We will differentiate the denominator 1 minus tan x by denominator square. Okay, 1 minus tan x whole square. Now this is 1 minus tan x. Okay, we will differentiate this. So Yusra, there are two functions, 1 and tan x. So one derivative is 0 and tan x derivative is sec square x minus this is 1 plus tan x and the derivative of this is 0 minus sec square x by this is 1 minus tan x square. Okay. We will open the bracket because we are not sure that these can be solved further or not. Maybe some terms can be cancelled out, but we are not sure. So we will open this bracket. So this will give you sec square x. Okay, then minus tan x into sec square x minus become plus. So okay, so better this minus this will become plus. So we will get a sec square x. And similarly, we will get a tan x into sec square x. Tan x into sec square x. Now in the denominator, we have this 1 minus tan x whole square. Now these two terms can be cancelled out. Finally, we get a sec square plus sec square, which will give us 2 sec square x, and then denominator will remain the same. Okay, Krishna, so in this case, these two terms get cancelled out. Okay, so it is better that if we will open the bracket and we will check if it is possible to cancel some terms or not.
Okay.
Okay, Yusra, this clear to you? Yusra, will you please reply me in the chat box? I guess you have some issues. So, Krishna, please start the next question.
So it will be by 1 minus tan x the whole square, right?
Yeah, it is 1 minus tan x whole square. Okay.
Okay.
1 minus tan x whole. Okay. So, Krishna, please start the fourth one. No issue, Yusra. Please start the fourth one. Okay. Please start the fourth one, and if you will face any doubt in this book, then I will solve it. Okay. And Krishna, whenever this one is done, then please inform me. I will check your answer. Sorry, I will repeat. Let me check if that is possible. No, that is not possible. Okay. Okay, Yusra, I will again solve this third one. So when you will differentiate this, then denominator will remain the same, and the numerator dx minus 1 plus tan x. Okay, derivative of 1 minus tan x by denominator square. Now this is 1 minus tan x, and this is 0 plus sec square x minus this 1 plus tan x, and this will give you minus sec square x. And Krishna, you can let me know the answer whenever you solve this, the last one. Now open this bracket. This will give you sec square x minus sec square x into tan x. Okay, and open this bracket. This will give you sec square x plus sec square x into. So this is tan x. Okay, sec square x into tan x by denominator, which is 1 minus tan x whole square. Now you can cancel out these two terms. So you will get a 2 sec square x by 1 minus tan x whole square. Okay, so hope this is clear to you. Now, user, please note down this and start the fourth one. Okay. You're welcome. And Krishna, please let me know if you have any doubt in this one. Okay. Okay, Krishna, very good. You have completed this question. And Yusra, shall I solve the fourth one? Yusra, shall I solve the fourth one? Okay, please click here. So I will write like this because it will save my one step. Now we will start from here. Okay, so as per the formula, what we will do, we will first write the denominator sec x minus tan x. After that, we will differentiate the numerator. So numerator is what? Sec x plus tan x minus, then numerator will remain as it is, sec x plus tan x, and we will differentiate the denominator. So that is sec x minus tan x minus tan x by we have sec x minus tan x whole square. Okay, then we have the sec x minus tan x, and the derivative, I will write the formula here, that the derivative of sec x is sec into tan. This sec into tan. Okay, you will get all these formulas, Yusra, in the previous videos. So, and for the tan, we have already discussed that its derivative is sec square x. So when we will differentiate this sec x, we will get a sec x and tan x. Okay, I'll leave one step where we will write like this derivative plus this derivative. Okay, then when we will differentiate the tan x, we will get a sec square x minus this sec x plus tan x. Now, when we will differentiate this one, then we will get a sec x into tan x minus, we will get here sec square x by, in the denominator we have sec x minus tan x whole square. Now open this bracket, you will get a sec x, you will get a sec square x into tan x plus multiply this, you will get a sec cube x, then multiply this, you will get a minus tan x into sec x, because this is tan square x, then minus, you will get a tan x into sec square x. Then open this bracket. Here you will get a minus sec square x tan x, then minus plus, you will get a sec cube x, then you get a minus sec x tan square x, and here you get a plus tan x into sec square x. Okay, So that's great that these two terms are get cancelled out. Then we have sec square x and tan x. Why we are getting this 2 times? So we have multiplied this, this 1, 2, 3, 4. Okay. Then we have multiplied this.
So it will be plus sec x tan square x, right?
Let me check. This term has came from here, so this is negative. That's correct. And from this one, we get what? Sec x into this minus minus. Yeah, this will give us plus. This is the biggest disadvantage of missing this step. Okay, sec x into this. So this is minus sec square x into tan x. This is plus, and this is minus, and this is plus. So everything is fine. Yeah, everything is fine. Okay, so here these will not cancel out. Okay, this will also cancel out. So finally, we get this one. Sec cube plus sec is 2 sec cube x minus tan square, and this one minus 2 tan square x into sec x by, in the denominator we have sec x and minus tan x whole square. Okay, Krishna and you, sir, this clear?
Yes, sir.
Okay, so Krishna, you can check that somewhere your answer is not matching. So somewhere there's a mistake.
So my minus sec x tan square x got cancelled, and I had minus 2 tan sec x square tan x. So I'll just check once.
Okay. Okay, then you sir, please note down this, and then we will start the next topic. Okay, please let me know once this is done. You're welcome. You're most welcome. Yes, sir. Once this is done, then please let me know. We will then start the next topic. Okay, sir, very good. Then we will start differentiation of a function of a function. Okay. So what is meant by this? There's a very interesting topic, differentiation of a function of a function. So from the name only, you were getting the hint that there must be two functions. Okay. So for example, if I will write like this, fx is equal to sine x square. Okay. Or suppose we have this one, fx is equal to sine x square, and suppose gx is equal to let me take any other function. Sine e to the power x, and suppose gx we have this one, e to the power x. Okay, so suppose if I will take like this, we have gx is this, and I will say we have hx is equal to sine x. Okay, and if in place of x inside this function, I will put this gx, then what I will get? I guess you already know that suppose we have this function gx is equal to x cube, then what is the value of g2?
8, sir.
This is 8. Okay, sir, this is clear? Okay, so whenever in place of x here you are putting any value, then in the function in place of x you will put the same value. Now we'll check here. Suppose inside this we are putting gx. Okay, now what is gx? Gx here is e to the power x. Then what is the value? What we will do in place of x, we will put this value as we have done over here. So what we will get? We will get a sine e to the power x. Okay, so you don't need to do this in any of the question. I just want to explain to you that this is not a single function. This is a two function. So we can say it is a function of a function. Okay, so this is clear to you that this is not a single function. From this complete, I just want to explain to you that there's not a single function, there's a two function. Okay, and these all things we will do in the 12th. There's a composition of a function we will do in 12th only. But is it clear to everyone? And this is not a single one?
Yes, sir.
Yes, sir.
Okay, now for the single function, for example, if we have this one, y is equal to sine x, okay, y is equal to tan x, y is equal to e to the power x, okay, and suppose we have this e to the power x into sine x, then please don't compare this one with this. This is a multiplication of two function, and this is not a multiplication. There are two functions, one inside the other, as we have checked here. Okay, inside this function h, if we will place a gx, then we get this. So this is a two function inside the next one, and this is a product of two functions. So please don't compare this with this. These both things are different. Now, for example, we have an x square and all these, whatever the functions we have differentiated till now, these all are single function. Okay, this is a different topic where we need to differentiate the function of a function. Means there is a function and inside that there is one more function. Okay, so we will try to differentiate this one. Okay, so if z is equal to fy, suppose this is one function, z is equal to fy, and inside this y there is one more function which is gx, then how we will differentiate this? Previously, if we have a question like this, y is equal to sine x, and how can we differentiate? We'll just differentiate like this, dy by dx is equal to d sine x by dx. Okay, but what happened when inside this function there is one more function? For example, this one, z is equal to fy, there is one more function, y is equal to gx. How we will differentiate this? We will write dz by dx. Finally, we need to differentiate it with respect to x because this will be given in the question. How can we differentiate this? We will differentiate first of all fy. As there is a variable y, then directly it is not possible for us to differentiate this with respect to x because this is y. So first of all, we will differentiate this with respect to y. Then we will differentiate y with respect to x. I know this is not clear to you, but I just want to tell you that whenever we have a function in which there is one more function, then we will not differentiate directly. Okay. We have two approach to solve these types of question, and we will take a very simple approach. Okay. So, for example, if we have a question like this, y is equal to sine x squared. Okay, and user for you, I will write this formula because this formula will be required in further questions. So this is nxn minus 1. Okay, user, if there is a x to the power n, then the answer will be nxn minus 1. Okay.
Yes, sir.
Okay. Now y is equal to sine x squared. Now, if we need to differentiate this, so first of all, we need to decide that what is the first function and inside that what is the other function. So if you will check this one, then the main function is sine, and inside the sine we have x squared. Okay, so I hope this is clear to both of you that main function is sine and inside sine we have x squared. Then how we will differentiate this? We always need to differentiate with respect to x because that will be given in the question. That differentiate this with respect to x. So finally, so firstly we need to write dy by dx. Second thing, sine x square, okay, with respect to. Suppose we have this sine x with respect to, if we will differentiate, then Krishna, what will be the answer?
Cos x.
Cos x. But please remember, we didn't differentiate this x. We have differentiated only sine x. So the derivative of sine is cos, and whatever the variable here, we will write like this. We never differentiate this one. Okay, but the condition is these two should be same. When we can differentiate this, when these two should be same. So the derivative of sine is cos, and this will remain the same, but the condition is these two should be same. So if I need to differentiate this sine, Krishna, then with respect to what I will differentiate it?
So the whole sine x square.
With respect to x square, because I need to differentiate sine. So what we have checked here, these two should be same. So if I need to differentiate sine, then I will differentiate with respect to x square.
Okay, sir.
Okay, but finally, with what respect I need to differentiate? X.
Yes.
Okay, so what I will do, I will differentiate this function again with respect to x. So till what time we will continue the differentiating? Till the time we do not get a dx. This is for the chain rule. Okay, this chain will occur till the time we get a dx. So here we get a dx. That's all. We'll not differentiate it further. Now, what's the derivative of sine?
So why are we differentiating x square?
Why we are differentiating? Because here, with respect to what we need to differentiate? With respect to x.
Yes, sir.
Okay, that's why. Or you can say if these two will cancel out, then finally you will get the same thing.
Okay.
Okay, you can understand in this way also. But always remember, we need to differentiate with respect to x. So we will continue the differentiating. In the future, we will see that we have a 4 or 5 functions. We will continue to differentiate this function until we get a dx. This clear?
Yes, sir.
Okay. So what's the derivative of sine?
Cos.
Cos. We will write cos. Whatever the angle is here, we will write here. We will not touch this angle because as per the formula, the x remain as it is. Okay. After that, what is the derivative of x squared?
2x.
2x. So we get a 2x into cos x squared. Okay, there is no need to note down this question. I will give you many questions on the basis of this. Y is equal to cos x cube. Okay, Yusra, for you, I will write this formula. Krishna, what's the formula of cos?
Minus sine x.
Minus sine. Okay. Again, please check if this is x, this is x, this is x. We will not differentiate this x. We will differentiate cos, so its derivative is minus sine. But the condition is these two should be same. Now dy by dx is equal to. Now, Krishna, please tell me with what respect we will differentiate this?
X cubes.
X cube. And we will differentiate x cube with respect to x. Now, what's the derivative of cos?
Minus sine.
Minus sine x cube. Okay, angle will remain the same and its derivative is 3x squared. Will not, okay, there's no need to write this one. Please check next. Suppose we have y is equal to tan x to the power 4. Dy by dx is equal to tan x to the power 4. So Krishna, with what respect we will differentiate it?
X power.
X to the power 4, then x to the power 4 with respect to
Dx.
dx. Okay. So what's the derivative of tan?
Sec square x.
Sec square. Okay, whatever the angle is here, we'll write like this only, and the derivative of this is 4x cube. Okay, Krishna, this clear?
Yes, sir.
Yusra, this clear?
Yes, sir.
Okay, very good. There is no need to note down any of these questions. Okay, we will start some questions. This is a complicated one, so please don't do this right now. Please let me know the answer of this. Y is equal to sine e to the power x. First of all, solve this, share your answer, then start this. And you got the answer?
Just a minute.
Okay. The power x cos, very good, Krishna. This is correct. So Krishna, please start the first one. And Krishna, almost this chapter is done. Okay, so which chapter shall we start in the next class? Is it trigonometry?
Okay, sir.
Okay. Cos 6 squared plus 22x. Very good, Krishna. Please start the next one. Okay, Krishna, before that, first we will discuss here. So what is the derivative of exponential function? This is again exponential. Okay, but again, we never differentiate this one. We differentiate this e, which remain as it is. Here, whatever the variable you have, it will remain as it is. We will never differentiate it. But the condition is this one and this one should be same. These two should be same.
Yes, sir.
Okay, now please try this question. Krishna, you can tell me the answer directly. There's no need to write down it. Okay.
So e to the power sine x multiplied by cos x.
Very good, Krishna. This is correct. Please try the third one. Just my voice is audible.
Yes, sir.
Okay, so Yusra, you can try this first question. Okay, and please hear your answer for the first one. And if you face any doubt, any difficulty, please let me know. I will solve.
Sir, is the answer sin x by x multiplied by cos x?
Well, sorry, the answer is
Is sin x by x multiplied by cos x?
no, not correct. If we will differentiate this log sin x. Okay, so first of all, we need to decide that what is the first one. So we have a log, and inside log we have a sin x. Okay, so what is the formula with respect to x? So these two remains as it is. We get a 1 by x. So we will differentiate this with respect to what?
Sin x.
Sin x. Very good. Then sin x with respect to
D of x.
d of x. Now what's the derivative of this?
1 by sin x.
1 by sin x. And what is the derivative of this?
Cos x.
Cos x. So cos by sin is what?
Sec x.
Cot
Yes,
x.
cot x.
Okay. Okay. So Krishna, is this clear?
Yes.
Okay. Then Krishna, almost we have completed this chapter. We have done all the topics. Now your homework is complete NCERT. Okay. Plus, Nirkush will share assignments with you. You need to complete that. Okay, this is your homework. And the only topic is remaining. We need to prove these formulas by the first principle. We need to do the two formulas, log x and derivative of exponential. Okay, so please remind me in the next class. We will do the proof of these two. Then we will start the trigonometry.
Okay, sir.
Okay. Okay, Krishna, then. Thank you.
Thank you, sir.
Okay, you're most welcome.